We start with redox reactions. Now, redox reaction mein redox, the word comes from reduction and oxidation. The majority of all the reactions that we do, chem mein, they're going to involve both reduction as well as oxidation. So, majority of reactions ko, we call all the reactions as redox reactions. Now, let's start with classical definition of oxidation. What do you mean by oxidation? Oxidation means the addition of oxygen, or we can say that oxidation is the addition of electronegative element, or oxidation is the removal of hydrogen or the removal of an electropositive element. Similarly, what exactly is reduction? Classical definition says reduction is the addition of hydrogen or the addition of an electropositive element, and it is the removal of oxygen or removal of electronegative element. However, we do not really follow the classical definitions. What we now follow is the modern concept or the electronic concept of oxidation and reduction. According to electronic concept, oxidation is the loss of electrons. So, in any chemical reaction where there is reduction and oxidation, one element will lose electrons, the other one will gain. So, loss of electrons is termed as oxidation, which will also define the number of electrons lost. We will define it as the oxidation number. And वही electrons which is gained by some other element in the chemical reaction, that is called as reduction. So reduction is gain of electrons. For example, let's say over here H2 losing an electron, each hydrogen will lose one. So we have 2H plus, loss of electrons, and let's say Fe plus 3, ferric ion, gaining an electron and becoming ferrous. Okay? This is, you can say, electronic concept or modern concept. Now people, in any reaction, the element which gains electron is your oxidizing agent. So oxidizing agent क्या करता है? It will oxidize the opposite element and itself undergo reduction. So always remember, oxidizing agent will gain electrons. So oxidizers or oxidizing agent का मतलब क्या होता है? Elements or substances which have the ability to remove electrons from others, oxidize others. These are called as oxidizers or oxidizing agents. Now, some examples I've written: F2, O2, halogens. Here, F2 or fluorine, people, we know that it's the most electronegative element in the periodic table. Also remember, it is the strongest oxidizing agent. Eventually we'll do the activity series or electrochemical series. वहाँ पे हमें ध्यान रखना है F2 is the strongest oxidizing agent available. Similarly, reducers or reducing agent. Reducing agent का क्या काम है? It will reduce the opposite element. So itself it will undergo oxidation. So a reducer or a reducing agent will lose electrons. The opposite element will gain electrons. So it itself undergoes oxidation and it oxidizes the, it reduces the opposite element. So what is a reducing agent? Substances which have the ability to reduce others or donate electrons to the other substances in a chemical reaction is called as a reducing agent or reducers. Now, we need to understand that by just looking at a particular compound, how can you identify whether it is an oxidizing agent or whether it is a reducing agent, whether it will undergo oxidation or it will oxidize the opposite element. For that, we need to first understand the concept of oxidation number. Now, what do you mean by oxidation number? Simple terms mein, it is the charge on an element in a compound, that's called as oxidation number. हमने एक simple concept किया था in chemical bonding which was called as formal charge. If you people remember, हमने ना formal charge किया था. Formal charge में what we were doing is we were trying to find the oxidation number on the element. So first of all, why oxidation number comes in the first place? Let's try and understand that. Let's say कि I have H2O, and I want to calculate the oxidation number over here. हम indirectly formal charge ही निकाल रहे हैं. How can we do this is, I know H2O, though it's a linear molecule, bent molecule, मैं इसको थोड़ा ऐसे बना रहा हूँ. Okay, now between oxygen and hydrogen, who's more electronegative? Oxygen is more electronegative, and hence whenever this bond breaks, ये जो bond के electrons है, who's going to take the electrons away? Oxygen. Now understand this. In this bond, this electron was given by oxygen, but ये जो electron था, the one which I have marked as X, वो X किसको belong करता था? Hydrogen को, because hydrogen had shared that, oxygen has shared one. Now what happens? Oxygen got back its electrons, that electron that it had shared, plus उसने किसका electron ले लिया? Hydrogen का, and hence oxygen develops a -1 charge because it has now gained an extra electron. That electron belonged to whom? And hydrogen develops a +1. Did you people get that? Yes or no? Similarly, if I break the left bond, what is going to happen? The electron which belonged to hydrogen, who's going to take that electron? Oxygen. So now, students, what will the overall charge on oxygen be? -2. And each hydrogen now has a, in short, in H2O, if I write the oxidation number, what will the oxidation number be on oxygen? -2. And the oxidation number on hydrogen? +1. Did you people get that? Overall, the molecule is neutral. How do you know that's neutral? Total negative charge कितना है? -2, which is being balanced by the total positive charge, which is also +2. In a neutral molecule, the sum of oxidation numbers, सब add करोगे, it will eventually come to 0. Let's try one more molecule to understand this थोड़ा सा better. Let's say I have hydrogen peroxide H2O2. We have not done H2O2 का structure भी, but we'll do that in the chapter hydrogen. It has an open book structure. Now this is H2O2. I have a question. If I break the bond between H and O, who's going to take the electron? O. So H will become +1, and this oxygen will gain a, if I break the right wala bond, who's going to take the electrons? Oxygen. Again oxygen will develop a, ये oxygen पे भी आ गया -1, and this hydrogen becomes a +1. I'll just plus लिख दिया तो भी चल जाएगा. Now tell me, if I break this bond between O and O, both have the same electronegativity, तो ये bond तो equally या homolytically break होने वाला है. Each electron which belonged to the respective oxygen, वो अपना electron वापस ले लेगा, but will it develop a charge? So final में क्या दिखेगा हमें? H plus O -1, O -1, and this is again, and hence in peroxide, what is the charge developed on oxygen? And the charge developed on hydrogen? +1. This is oxidation number. Anyone who don't understand this? Now there's another concept called as oxidation state. Majority of times हम oxidation state and oxidation number एक साथ use कर सकते हैं. I'm saying majority of the time, not all the times. But we will do some special oxidation cases where number अलग होता है and oxidation state अलग होता है. I repeat, number will be different and state will be different. When we discuss that, we'll come to that. Now, in order to find oxidation numbers, we have certain rules. Now let's go through these rules, और ये rules बहुत important है. This will help us find oxidation number या oxidation state किसी भी element का in a compound. Rule number 1. The oxidation number of any atom in an element in its elemental state is 0. What does that mean? What is the elemental state of hydrogen? It's a gas. So if I just have hydrogen in its elemental state, which is H2, in any particular reaction, तो H2 के ऊपर का oxidation state क्या होगा? Similarly, O2 gas elemental state, N2, Cl2, P4, NaMg, बहुत सारे example लिख सकते हैं. For example, Fe. So this is their normal elemental state. They're not in any combined or a compound के form में. So for example, if I just have Na, तो Na का oxidation number is 0. But if it is in the form of NaCl, so we know that Na will transfer that one electron, so Na पे charge हो जाएगा, +1 and Cl will become -1. So in a combined form or in a compound के form में, it will develop oxidation state, but in its elemental state, it will remain 0. Second rule, group 1 elements. Give me all the elements of group 1. Lithium, sodium, potassium, rubidium and cesium. Francium पे नहीं जाएंगे, cesium पर. All the group 1 elements in their compound form, not in their elemental state, will always carry charge +1. And group 2 elements. Give me the elements of group 2. Beryllium, magnesium, calcium, strontium, barium. Barium पे रुक जाता है. Group 2 elements, again in compound form, they will always carry a charge of +2. With me? Second rule. Third rule. The oxidation number of hydrogen in majority of all its compounds is always +1. But in ionic hydride का मतलब the elements of group 1 and group 2 form compounds with hydrogen जिनको हम hydride बोलते हैं. For example, LiH lithium hydride, NaH sodium hydride, KH, so on and so forth. We know that Na will always carry a charge of +1 in its compounds. So hydrogen here has to be -1. Similarly, magnesium +2. So उसको balance करने के लिए each hydrogen will also carry a +1 because there are 2 hydrogens. Pardon me, not +1, -1. Similarly, organic में we will write some reducing agents such as lithium aluminum hydride. The name itself says hydride, मतलब hydrogen will carry -1. What is the charge on lithium? Since it's a group 1 element, +1. So what is the charge on aluminium over here? +3. Because overall it has to be neutral. एक और एग्जाम्पल ले लेते हैं. सोडियम बोरोहाइड्राइड, अगेन अ गुड रेड्यूसिंग एजेंट, NaBH4. इस पे हाइड्रोजन पे -1. वी नो दैट सोडियम विल बी +1. अब टोटल कितना हो गया? +1 और ये -4. तो पूरे को बैलेंस करने के लिए बोरॉन हैज टू बी +3. So in ionic hydrides, remember carefully that hydrogen will carry a -1, and hydrides are very important reducing agents which we will use in organic chem. Chalo, next. the oxidation number of oxygen. अब 10 स्टैंडर्ड तक तो हमने इन डिटेल पढ़ा है. ऑक्साइड्स पे the oxidation number of oxygen will always be people -2. -2 मतलब basically oxide. But in case of peroxide, we just did H2O2. In case of peroxide, what will the charge on oxygen be? -1. So remember, in peroxide, the charge on oxygen is -1. In superoxides, see potassium पे charge क्या है? +1. So to balance the +1, oxygen has to carry a -half. Because there are 2 oxygen atoms. I repeat, potassium पे charge कितना है? +1. Let the charge on oxygen be x. So 1 plus 2 into x. Overall molecule is neutral. So 2x is -1. So x पे charge कितना हो गया people? -half. Similarly, यहाँ पे ध्यान से compounds with fluorine. Now people, fluorine is the most electronegative element in the periodic table. So the charge on fluorine is always going to be -1. अब अगर फ्लोरीन पे -1 है तो in OF2, what is the charge on oxygen? Same method, let the charge on oxygen be x. So x plus, how many atoms of fluorine do I have? 2. Each fluorine is carrying what charge? -1. So total कितना हो गया? 0. Why? Because it is neutral. X minus 2 is 0. How much is x? +2. So charge on oxygen over here is +2. Similarly, in O2F2, can someone find the charge for me? O2F2 पे भी निकालते हैं. How much is oxygen? Sorry, fluorine -1. Let oxygen be 2x plus 2 into -1 is 0. So 2x is 2. X is so oxygen carries positive oxidation state with fluorine. Please remember this. And because oxygen से ज़्यादा electronegative is only fluorine in the periodic table. Getting that? चलो. Next rule. The oxidation number of fluorine in all of its compounds is -1. But if I look at other halogens, which are the other halogens? IF, ICl and Br. Their electronegativity depends on which is the other element they are bonded to. इसका मतलब क्या है? Let's say I consider IF3. I want to know the charge on iodine. What is the charge on fluorine? -1. Let the charge on iodine be x. So x plus 3 into -1 is 0. So x पे charge कितना आ गया? So in IF3, iodine पे charge +3. In ClF3, charge on chlorine +3. BrF3, charge on bromine +3. What about HClO? HClO, charge on hydrogen +1. Charge on oxygen -2. Charge on chlorine, let that be x. So 1 plus x minus 2 is 0. X minus 1 is 0. So x कितना हो गया? So charge on chlorine over here is, similarly charge on chlorine over here is +3. Next rule. In ionic state, the oxidation number is nothing but the charge on the ion. What does that mean? Ionic state, ferrous, charge on Fe is +2. Ferric, charge on Fe +3. So ionic state में directly दिया है, the oxidation number is nothing but the charge that it is carrying. Next, the algebraic sum of oxidation number of all the elements in a neutral compound is 0. अब तो जितने भी एग्जाम्पल लिए सब न्यूट्रल कंपाउंड वाले ही लिए. Next. Now we come back to oxidizing and reducing agents. How do I identify if any particular compound is an oxidizing agent? Yeah, it is a powerful oxidizing agent. A simple way to identify this is, let's pick any example here. So let's say I start with KMnO4 and I want to know the charge on Mn. Potassium is group 1 element, charge +1. Oxygen -2. Let the charge on Mn be x. So 1 plus x plus 4 atoms of oxygen. Each atom is carrying a charge of -2. So 1 plus x minus 8 is 0. So how much is x? +7. If I look at manganese, atomic number 25, electronic configuration, argon 4s2, 3d5. The maximum oxidation state which a D block element can show is the sum of the electrons in the ns and n-1 d orbital. I repeat, the maximum oxidation number that a D block element can show is the sum of the electron in its ultimate and penultimate shell. मतलब ns and n-1 d. So 5 plus 2, 7. Manganese can show a maximum oxidation state of +7. What that means is manganese has already given away 7 electrons. It cannot give any more than that. Now it can only accept electrons, and hence it will act as a very powerful oxidizing agent because it has given already all it had. Now it will only accept. So if any element, and especially if it is electronegative और वो उसके मैक्सिमम ऑक्सीडेशन स्टेट पे है, अब उससे ज्यादा नहीं दे सकता, it will always and always try to gain electrons. That is, it will be a very powerful oxidizing agent. Let's take one more example. HClO4 कहीं पे तो लिखा है, या KClO4 और HClO4 दोनों चल जाएगा. Chlorine. Can someone find the charge on chlorine? Hydrogen is +1, oxygen is -2. Let chlorine be x. So 1 plus x plus 4 into -2 is 0. 1 plus x minus 8 is 0. x कितना हो गया? +7. So chlorine is also in +7. मतलब chlorine has given away every electron, actually shared every electron it had. यहाँ से chlorine will only want to gain electrons. So chlorine, yes, it's an electronegative element, plus in its maximum oxidation state, it will try to gain as many electrons as possible. Did you people get that? ठीक है? So this is how you identify a powerful oxidizing agent or an oxidizing agent. Similarly, how do you identify reducing agent? If the element is in lowest oxidation state. What that means is, if I pick H2S, what's the charge on sulfur यहाँ पे? Hydrogen is +1, so sulfur is, that's its lowest. From here, sulfur will only want to give electrons, and hence it's a strong reducing agent. Wherever it can increase its oxidation number, it can behave like a reducing agent. Similarly, if an element is in between its oxidation states, for example, if I look at nitrous acid, HNO2, nitrogen पे charge यहाँ पे people, this is +1, this is -2. let nitrogen be x, so +1 plus x -4 is 0. x की वैल्यू कितनी हो गई? +3. Nitrogen can go from +3 to +5. How do I know that? Because in nitric acid HNO3 nitrogen पे charges, so HNO2 can donate electrons, go from +3 to +5, which means it can behave like a reducing agent. It can also gain, yes, it can also gain electrons and go from +3 to +2 or +1 till -3 and behave like an oxidizing agent. So nitrogen is an intermediate state where it can gain also electrons, where it can also lose electrons. So such elements can behave both as oxidizing agents as well as reducing agents. HNO3 नहीं कर सकता, यहाँ पे nitrogen is already +5. So HNO3 is a very powerful oxidizing agent. HNO2 is, that's not the case, because nitrogen here is +3. It can go to +5, matlab it can give away 2 more electrons, so it can behave like a reducing agent. But at the same time, +3 say it can become +2 +1, which means it can gain also electrons. So HNO2 acts as both oxidizing agent as well as reducing agent, because it is in an intermediate oxidation state. This is how, students, you can identify whether an element is an oxidizing agent or a reducing agent, or probably even both. And this is very important even in organic. Chalo, now there are some compounds over here. Whatever is the underlined species, I want you to calculate the oxidation number. Okay. Students, please check your answers. Make sure आपको वही oxidation number मिला है जो हमें यहाँ पे मिला है. And now we need to consider some very special cases. Let's start with the first one, students. HCN. अब HCN को अगर हम ध्यान से देखें, HC, यहाँ पे स्टूडेंट्स जो थर्ड बॉन्ड है that is called as a coordinate bond. Coordinate bond में what happens is there is a donor atom and there is an acceptor atom. तो यहाँ पे आपका donor है nitrogen and the acceptor is carbon. Before we directly find the oxidation number, एक छोटा सा rule देखते हैं. So let's say, students, there is a coordinate bond from A to B. मतलब A आपका donor है, B is your acceptor. And if A is more electronegative, if the electronegativity of A is greater than the electronegativity of B, A की electronegativity is more than B. Now what happens in this case is, see, A ने B को electron तो दे दिए, but since A is more electronegative, the electrons remain close to A, and hence in this case no charge is developed. Okay. However, if the case is opposite, let's assume if the electronegativity of A is less than the electronegativity of B. In that case, the charge developed on B, because now what has happened is A के electrons B ने अपनी तरफ ले लिए हैं, will be -2 and the charge on A will be +2. Let's understand this again. The electronegativity of B is more than A. A donor है, A has given electrons to B, but the electronegativity of B is more. So what will B do over there? Pull the electrons towards it, and hence both the electrons which actually belonged to A are closer to B. Hence B will develop -2 and A develops +2. Now the same rule we need to apply here. देखो स्टूडेंट्स हाइड्रोजन तो +1 है, वो तो हमको पता है, तो ये +1 की वजह से ये कार्बन पे आ जाएगा -1. नाउ लुक एट कार्बन एंड नाइट्रोजन, ये दो बॉन्ड है, नाइट्रोजन इज मोर इलेक्ट्रोनेगेटिव देन कार्बन, तो ये दो बॉन्ड के इलेक्ट्रॉन्स के वजह से कार्बन विल बी -2, sorry, nitrogen will be -2 and carbon will be +2. And students, if I look at the coordinate bond is from the more electronegative atom to the less electronegative atom. I repeat, from the more electronegative atom to the less electronegative atom. So the charge won't be developed because of the coordinate bond. तो HCl पे total charge निकालना है, तो hydrogen will be +1, carbon will be -1 +2, carbon will be +1, and nitrogen will be -2. I hope students you got that. But अब ये केस कंसिडर करते हैं where you have HNC, isocyanide, we call it as isocyanide. So hydrogen will remain +1. Because of this hydrogen, carbon पे पहले आ जाएगा, sorry, nitrogen पे here will have -1. Now out of again the three bonds, one bond is coordinate. Again, from donor to acceptor, donor is more electronegative, so no charge will be developed because of the coordinate bond. And because of these two bonds, nitrogen will develop -2 and carbon will develop +2. तो अगर हम पूरा चार्ज निकालें in HCN, hydrogen is +1, carbon is -3 and nitrogen is +3. I hope students you have understood, and this is a very, very important concept. Next, we have NiCO4. Now students, these are a very special compounds. They are called as coordination compounds. We'll study more about coordination compounds in 12th standard, but कुछ examples ले लेते हैं. NiCO4, now CO को हम बोलते हैं यहाँ पे carbonyl, and it behaves, it has a very special behavior. इसको हम बोलते हैं it's a ligand. I repeat, it's a ligand, Ligand. Charge on carbonyl is 0, so 0 into 4, तो निकल पे भी यहाँ पे 0 चार्ज होगा. Similarly in FeCO5, CO पे charge is 0, nickel is also 0. Actually students, D block elements can show 0 oxidation state when they are bonded to such neutral ligands. ये देखते हैं students, K3FeCN6. Again, this is also a coordination compound. यहाँ पे हमारा ligand is cyanide. Ligand पे charge -1 है, potassium पे +1. Let the charge on Fe be X. So 3 into +1, this is 3 plus Fe पे charge पता नहीं, हम put करेंगे X plus 6 cyanide, each -1. We call it cyano, but I'm calling it cyanide temporarily. तो X पे charge आ गया +3. That is, the charge on Fe is +3. Next students, NOCl. Now NOCl में what we need to first understand ना students, the structure looks like this. दो N यहाँ बना है, but it is actually the middle atom sodium है and not oxygen. जब हम इसको ऐसे लिखते हैं तो it feels as if oxygen is the central atom, but the central atom is nitrogen. So charge oxygen पे -2, chlorine here is -1, nitrogen पे charge हो जाता है students +3. So I hope everyone understood this example, but students, we have a very, very important part after this where we need to understand special cases of oxidation numbers. These special cases are very important because जैसे दिखता है वैसा होता नहीं. For example, let's start with H2SO5, which is also called as kerose acid or peroxomonosulfuric acid. Now if I try to find the oxidation number on sulfur using the normal standard method जो हमने अभी तक पढ़ा है, the oxidation number on sulfur here will come as, so we know hydrogen is +1, oxygen is -2, so +8. If we follow the normal method, हमें तो oxidation state मिलेगा on nitrogen as +8, I'm sorry, on sulfur as +8, but +8 is not possible for sulfur, and hence in this case, students, what we really need to understand is we need to know the structure of the molecule. Now the structure of the molecule is something like this. This is called as a peroxy linkage. Okay, so let's understand this. ये single bond, oxygen is more electronegative, so because of this single bond, sulfur पे develop होगा +1. राइट में भी सिंगल बॉन्ड, सो ये बॉन्ड ब्रेक होगा तो ऑक्सीजन पे अगेन, सल्फर पे अगेन डेवलप होगा +1. ऊपर डबल बॉन्ड ब्रेक होगा तो सल्फर पे +2. मैं नीचे का डबल बॉन्ड ब्रेक्स, सल्फर पे +2. ओवरऑल चार्ज +2 +1 +2 +6, so the charge on sulfur is actually +6. And hence students, यहाँ पे we need to carefully understand this, that if you just look at the molecule as a whole, आपको लगता है charge +8 आएगा, but +8 तो possible ही नहीं, and hence we need to know the structure of the molecule in order to correctly identify what exactly is the oxidation number. Let's take the second example, Marshall's acid H2S2O8. again direct करेंगे तो हमें गलत oxidation number आएगा. Let's do it via the structure of the molecule. So the structure of the molecule again is something like this. इसमें भी there is students a peroxy linkage, peroxo linkage है यहाँ पे. Now this becomes very easy. Again आप इस सल्फर को देखो, एक single bond on the left, single on the right, which means +1 +1, एंड जहाँ पे भी डबल बॉन्ड है +2 +2, सो ये सल्फर पे भी चार्ज आ गया स्टूडेंट्स +6. द चार्ज ऑन दिस सल्फर इज ऑल्सो +6. Let's continue some more very important examples. Let's say we have CrO5. Traditional method से if I try to find the oxidation number on chromium, तो यहाँ पे x की वैल्यू आ जाएगी स्टूडेंट्स +10, but that is not possible. Chromium can maximum go to +6 because we know that for D block element, chromium atomic number 24, electronic configuration argon 4s1 3d5. So sum of the electrons in 3d and 4s will give us the maximum oxidation state. So the maximum oxidation state is 1 + 5 matlab 6, and hence we need to know the structure. The structure is something like this. इसको हम बोलते हैं butterfly structure. And so students, wherever single bond, +1 charge, so +1 +1 +1 +1, and this double bond, so the charge developed when you break the double bonds will be +2. So total charge देख लिया हमने chromium पे, and the total charge students here comes as +6. I hope everyone got this. Similarly, if I look at CrO8, I want students यहाँ पे आप direct method से भी try करना. If you try direct method से, we will get the charge on chromium as, let's say that be x. ये है +1, ये है -2. So 3 + x -16 is equal to 0. x आ जाएगा +13. And we know that students +13 तो possible ही नहीं है. and hence when we try to understand the structure looks like this. So if I look at all the bonds, all are single. If I break these single bonds, तो मेरे पास 5 single bonds हैं. Actual charge on chromium in K3CrO8 is +5. नेक्स्ट स्टूडेंट्स, यहाँ पे हमारे पास कार्बन सबऑक्साइड, ठीक है, C3O2. Now students, I wanted to also explain the difference between oxidation number and oxidation state. Now students, C3O2, if I directly try to find the charge, oxygen is -2, so carbon here will be +4/3. Students, fractional charge तो possible नहीं है, so we need to understand the structure, and the structure is like this. This is the structure of carbon suboxide. Now if I look at the first carbon, जब ये डबल बॉन्ड ब्रेक होगा तो ये कार्बन पे चार्ज डेवलप होगा +2. When this double bond breaks, ये कार्बन पे चार्ज डेवलप हुआ +2. But there will be no charge developed on this carbon because it is doubly bonded to carbon atoms. तो ये कार्बन पे तो कोई चार्ज डेवलप नहीं होने वाला. As a result of which, if I observe this, there are 3 carbon atoms, total charge +4, तो 4/3, and hence 4/3 is oxidation state. But when you look at the individual oxidation values, वो oxidation number, तो हम बोलेंगे oxidation state of carbon in carbon suboxide is +4/3, but the oxidation number on carbon atoms is +2, +2 and 0. I hope students you got the point. Now let's look at this tribromo octoxide. ठीक है, tribromo octoxide, Br. पहले हम स्ट्रक्चर अंडरस्टैंड करते हैं. So if I try to find the oxidation state, oxygen here is -2, so bromine हो जाएगा +16/3. But if I try to find oxidation number, so ये bromine will be +6, because students, double bond, double bond, double bond, when you break the double bond with oxygen, it will develop +2. ये single bond break होने पे कोई charge develop नहीं होगा, because the bond is between bromine and bromine. Similarly, ये bromine पे charge हो जाएगा +4, because double bond with oxygen ऊपर, double bond with oxygen नीचे, and ये bromine पे भी charge आ जाएगा +6. So if you look at individual oxidation numbers, +6, +4, +6 add करो, हो जाता है 16, divided by number of bromine atoms 3, 16/3 मिल गया oxidation state. But +6, +4, +6 is the oxidation number. Next, CaOCl2 people is bleaching powder. If I look at bleaching powder, very important, bleaching powder को हम ऐसे डिवाइड करते हैं when we want to know the charge. So calcium is +2, charge on OCl- is -1, and charge on Cl is -1. OCl- पे further we can say that the charge on oxygen is -2, but the charge on chlorine is +1. This is how you can find their individual oxidation numbers. In NH4NO3, इसको भी हमें, we can look it from 2 different perspectives, NH4 plus and NO3 minus. So the charge on the first nitrogen, students, is -3, and the charge on nitrogen over here in NO3 minus is +5. So in NH4NO3, the two nitrogens carry different oxidation numbers. Fe3O4 is also a very special compound, people, because if you directly try to find, यहाँ पे आ जाता है +8/3, but FeO4 is actually of two parts, जिसमें होता है एक part FeO, the other part is Fe2O3, which means one atom of Fe over here is actually carrying a charge of +2, and these two Fe may each Fe carries a charge of +3. So in the three atoms of Fe3O4, एक एटम पे चार्ज है +2, बाकी दो Fe atoms पे students the charge is +3. That is how you look at it. Finally, students, I want you to try this as a homework question. Structure बना के करना, then you'll get a thoda better idea about this. And these are all the most important examples of special cases of oxidation number. In the next lecture, students, we will start with balancing of redox reactions. There are two methods of balancing redox reaction. The first method is called as the ion electron method, and the second method is called as the oxidation number method. We'll do both the methods next class. Thank you so much, students. Please make sure, if you really like the lecture, to subscribe and share it with all your students who are preparing for entrance exams. Thank you so much.